So let's look at the solutions to Wednesday's homework where you were doing a bit more practice with composite functions. So on pages 240 to 241, you had questions 2 to 5 to practice a bit more with composite functions. And in this case, the notation for the functions was given as f such that x is mapped onto, but we can just straight away go and replace that with f of x and g of x instead, because it's a little bit easier to have it a standard way all the time. Okay, answering questions on it then. The first thing we were asked to do was to find f of 3. So this means we were replacing x with 3 in the definition of f. So that gives us 7. And we were asked to find g after f of 3. So that means that I find this answer, which I have, and I plug it into g. So 4 times 7 minus 3, which is 28, take 3, which is 25. You can use your calculator as well, of course. Okay, so very much the same kind of thing that we've been doing all along. Part 3, we're asked for, it says fg minus 2, but we know that means f of g of minus 2. So first we find g of minus 2, which is 4 by minus 2, take 3. That's minus 8, take 3, that's minus 11. You can use your calculator, of course, especially if you're worried about making a mistake with signs. And then f of g of minus 2 is f of minus 11. So that's 2 times minus 11 plus 1, which is minus 21, minus 22 plus 1, which is minus 21. There's our answer there. So those are the answers so far. That's just a midway step. Now part 4, we're asked to find g of f of x. Okay, so this isn't maybe something that we've done before with our own practice. We already know what f of x is. It is 2x plus 1. So this is g of 2x plus 1, which means we're replacing x with 2x plus 1 in the formula for g here. So that gives us 8x plus 4 minus 3, which is 8x plus 1. And that's the final answer there. Okay, so this one, especially for higher level maths, is something that you definitely need to be able to do. Okay, let's move on then to question 3. So in question 3, we have functions f and g, and again they use the f such that x is mapped onto notation, and we're just going to straight away use this. So we've got f of x is 2x minus 1, and g of x is x squared plus 2. First part of the question asks us to find f of g of minus 2. So first of all, we need to find g of minus 2. So g of minus 2 is minus 2 squared plus 2, which is 4 plus 2, which is 6. So then this is going to be f of 6, which is 2 by 6 minus 1, which is 11. Just be clear with these when you're doing a few different calculations as you go what the answer is. So my answer is 11. Okay, the next part asked us to find g after f of a half. I'm just using the different ways that we might call these. G after f of a half. So first of all, we need to find f of a half. So that's 2 by a half minus 1, which is 1 minus 1, which is 0. And then g of f of a half means I need to find g of 0. So g of 0 is 0 squared plus 2, which is 2. So the answer there is just 2. Part 3 asks us to find f of g of x. So these are really important. That means I'm finding f of whatever g's definition is, which is x squared plus 2. That means everywhere I have x in the definition of f, I'm replacing it with x squared plus 2. Then I multiply out the brackets, 2x squared plus 4 plus 1, and that is 2x squared plus 5. So you could always find this formula first and then plug in these values. For example, if I put a half in here, I'll get, this is the other way around. If I put a minus 2 in here, I'll get 2 by 4, which is 8. 8 plus 5 is 11. No, it's not. 8 plus 5 is 13. I'm just going to double check these now. So g of minus 2 was, I see. G of minus 2 was 4 plus 2, which is 6. Yeah, that's correct. And then I do twice that. Which is, that's where I went wrong. Okay, I should have gotten exactly the same answer. And the problem here was that I wrote down a plus instead of a minus. Okay, so this should have been 2x squared plus 3. Okay, and my point was that if I plug minus 2 into this formula, I should get the same answer as I have up here. So let's try it now. 2 by 4 is 8. 8 plus 3 is 11. Okay, good. So maths isn't suddenly broken. That was part 3. And then they also wanted us in part 4 to find the other way round, g of f of x. So this means that I'm going to find g of f's formula, 2x plus 1 here. So that is 2x plus 1 all squared, and then add 2. What does that give me? I'll square out this bracket. That gives me 4x squared, square the first, double the product, 4x, 1 by 2x is 2x, and then double it, plus 1 plus 2. So that gives me 4x squared plus 4x plus 3. And what I said is that if I put a half into this, I should get 2. Should get 2. Half into this, that gives me 1 plus 2, which is 3. Again, I keep using a plus where I should be using minus. We can see that checking my algebra afterwards is helping me fix it. So now, if I put a half into this, I should get 1 minus 2 plus 3, which is indeed 2. So check there. Okay, if you don't know what I'm doing there, don't worry about it. I'm just checking that this should give me the same answer as putting the half straight into this formula, because they're both g after f. One is just getting me a formula for g after f, whereas the other one is doing it step by step. Okay, let's go on then to question 4. And now we've got some powers in our function definitions, but it's exactly the same as what we've done before, replacing the x value with whatever is in brackets. So f of x is 2 to the power of x minus 1, and g of x is 3 plus 4x. So they want us to find f of g of x. That means that is f of 3 plus 4x. And that is 2 to the power of, put all of this in instead of x, 3 plus 4x minus 1. And we can just tidy that up. That is 2 to the power of 4x plus 2. Okay, so all we're doing is replacing the x value with whatever's in brackets. Now the second one might be a little bit more difficult. They want us to find g of f of x. So that means that I'm finding g of 2 to the power of x minus 1. I'm replacing x in the g function with 2 to the power of x minus 1. Okay, if you get this far and leave your answer like this, you will get high partial credit. Now we need to go over indices a little bit, And we are going to be doing that next, but I'm going to show you something first, because from your junior cert indices, you should know that when we multiply the bases, we add the powers. Don't worry if you can't do this step yet. That's 2 plus, I'm adding these powers, x minus 1, which is 3 plus 2 to the power of x plus 1. And that's how they would expect our answer to look for full credit. But at the moment, before we go over indices and logs, which is what we're doing next, this is where I'd expect you all to get to. This step here, a little bit more complicated. Okay, then question 5. We've got f of x equal to 3x squared and g of x equal to 2x plus 1. And first of all, they want us to find f of g of x. So that is f of 2x plus 1, which means we're replacing the x in the f formula with 2x plus 1. So I square out my brackets. That gives me 3 by 4x squared plus 4x plus 1. Multiply that all the way out. 12x squared plus 12x plus 3. Okay, so that's the answer to part 1. And then they said, hence solve the equation f of g of a equal to g of 1. So first of all, we need to find g of 1. And g of 1 will be 2 by 1 plus 1, which is 3. So this is 3. And this is that formula up there, but use a instead of x. And you know what, if you wanted to keep using x and just solve it, you actually should get full marks for that. So 12a squared plus 12a plus 3 equal to 3 is what we're actually solving here. 12a squared plus 12a plus 3 equal to 3. And we bring everything to one side. 12a squared plus 12a plus 3 minus 3, they cancel. We've got that equal to 0. Divide across by 12 because we can, and we've got a squared plus a equal to 0. Factorize by taking out a common factor. And so then we're solving this part. Either a is equal to 0 or a is equal to minus 1. Where are those coming from? The first factor equal to 0 or the second factor equal to 0. So there are two values for a which will make this true. When a is equal to 0, this will be true. And when a is equal to minus 1, this will also be true. Okay, so in terms of what you're expected to do at this point, if you struggled with questions 4 and 5, that's actually okay for what we want to be able to do right now. Those are difficult questions, but I would expect everyone to be able to do questions 2 and 3, and especially these parts here where we're subbing in the formula. You really need to be able to do those. Okay, thank you.